let's take a quiet moment and think about something we almost never really think about. Let's think about time. What is it? For almost all of human history, the answer seemed obvious. It's the clock on the wall. It's the sun rising and setting. It's the steady, unwavering march from yesterday through today and into tomorrow. Our intuition, our deep gut feeling, tells us that time is an absolute. It's a giant cosmic clock sitting somewhere in the universe, ticking away at the exact same speed for everyone and everything everywhere. This was the view of Isaac Newton. He saw time as a great invisible river flowing at one constant unchangeable rate. A second for you sitting in your chair is the exact same second for someone on the other side of the world, and the exact same second for a star in a distant galaxy. It's simple. It's comforting. It's the background of our lives, the stage on which the story of the universe unfolds. And then just over a century ago, a young patent clerk named Albert Einstein looked at this simple, comforting idea and tore it all down. He proposed something that at the time sounded like madness. He suggested that time is not a fixed, rigid background. It's not a stage. Instead, time is a character in the play. It's a thing. It's a part of the very fabric of the cosmos, a fabric that can be bent and stretched and warped. This idea is deeply unsettling. It's one of the hardest concepts in all of science for our minds to accept because it goes against everything we feel in our bones. The very notion that two people could experience time differently, that one person's clock could physically, genuinely tick slower than another's, it just feels wrong. It's like being told that the colour blue doesn't actually exist or that the ground beneath your feet isn't solid. It's a collapse of our most fundamental intuition. But this is the core of Einstein's revolution, the idea that launched us into the modern world of physics. The core concept is this: time is relative. What does that really mean? It means the rate at which time passes for you is not a universal constant. It depends on your circumstances. Specifically, it depends on two things: how fast you are moving through space and how strong the pull of gravity is around you. Let's just focus on the first part for a moment: motion. Einstein declared that there is a cosmic speed limit. Nothing in the universe can travel faster than the speed of light. That's about 300 million meters per second. It's a number so vast that our minds built for a world of walking and running can't truly grasp it. But this speed limit is the key. He realized that space and time are connected. You're always traveling through a combination of them, which he called spacetime. And the faster you move through space, the slower you move through time. Let's try a famous thought experiment. Imagine two twins, Anna and Ben. Anna stays on Earth. Ben gets into a futuristic spaceship that can travel at incredible speeds, let's say 99% of the speed of light. He blasts off, goes on a long journey to a distant star, and then turns around and comes back. For Anna, back on Earth time has passed as it always does. The trip for her took 20 years. She has aged 20 years. The clock on her wall has ticked off 20 years. But for Ben, hurtling through the cosmos at nearly the speed of light, something truly strange has happened. His time slowed down. From his perspective on the ship, everything was normal. But relative to Anna on Earth, his clock ticked slower. His heart beat slower. His thoughts processed slower. When he lands his ship back on Earth and steps outside, he finds his twin sister Anna is 20 years older than when he left. But Ben has only aged perhaps 3 or 4 years. This isn't a trick. It's not a biological quirk or a broken clock. Ben has genuinely experienced less time. He is now physically younger than his twin. This is the twin paradox. It sounds like a paradox, but in physics it's simply a fact. So why then don't we notice this in our everyday lives? When you fly in a jet plane, you're moving at 500 miles per hour. Why don't you come back a few minutes younger? The reason is the sheer overwhelming speed of light. Our everyday speeds are just a tiny, pathetic fraction of that ultimate limit. The effect is there, absolutely. But when you're in a car or even a jet, the amount of time you save is so small, we're talking billionths of a second, that it is completely undetectable by our senses. Our intuition was built for this slow-moving world, so it works perfectly fine here. But our world isn't the whole world. The philosophical implication of this is staggering. It means there is no single universal now, that idea of a cosmic clock that everyone in the universe can agree on. It's an illusion. Time is local, time is personal. My now is defined by my motion and my place. Your now is defined by yours. If we're just sitting in the same room, our nows are basically identical. But if I'm on Earth and you're on Mars, our nows are slightly out of sync. And if you are in that high-speed spaceship, your now is dramatically different from mine. And we know for a fact that this is true. This isn't just a wild theory. In the 1970s, scientists performed an experiment. They took hyper-accurate atomic clocks so precise they wouldn't lose a second in millions of years. They put some of these clocks on commercial jetliners and flew them around the world while leaving identical clocks on the ground. When the planes landed and they compared the clocks, the ones that flew were measurably behind the ones that stayed on the ground. They had experienced less time. The difference was tiny, just a few nanoseconds, a few billionths of a second, but it was real. And it was exactly the amount Einstein's equations predicted. In fact, you use this principle every single day. The Global Positioning System, or GPS, that your phone uses to tell you where to turn, it only works because of relativity. The satellites orbiting the Earth are moving very fast, which slows their clocks down just like our spaceship, but they're also in weaker gravity, which actually speeds their clocks up, a whole other story. The system has to be precisely engineered to account for the fact that time literally runs at a different speed for those satellites than it does for us on the ground. If the engineers had ignored Einstein and just used Newton's old intuitive idea of time, the entire GPS system would fail in less than 2 minutes. Your map would drift off by miles every single day. So this is the first great challenge in our journey. The challenge isn't really the mathematics. The real challenge is emotional. It's the challenge of letting go. It's the challenge of accepting that our most basic fundamental intuition about reality, the simple, steady, reliable tick-tock of one universal clock, is just a story. A useful story for our everyday lives, but a story nonetheless. The universe is so much stranger, so much more flexible, and so much more personal than we ever dared to imagine. And this realization, this collapse of our shared intuition, is only the beginning. In our last journey together, we came to accept a strange and wondrous idea that time isn't a steady ticking clock for everyone. It can stretch and it can squeeze. We've accepted what happens. And now, as we settle in, let's gently explore the how. How does this happen? How can the universe have a rule so fundamental yet so flexible? To understand this, we have to change the way we see, well, everything. For centuries, we lived in a universe that felt like a grand, predictable machine. This was the universe of Isaac Newton. In his view, space was like a giant empty box, a rigid, unchanging stage where all the events of the cosmos played out. And time was a single universal river flowing at the same steady rate for every person, every planet, and every star, everywhere in the cosmos. It was simple, it was comforting, but it was separate. Space was here and time was there. They were two different things. Then at the dawn of the 20th century, a young patent clerk named Albert Einstein invited us to see the universe in a completely different way. He asked us to imagine that the universe wasn't a machine, but a fabric, a single unified stuff, where space and time are not separate at all. He imagined they were woven together so tightly that you cannot affect one without affecting the other. He called this new fabric spacetime. This isn't just a clever name, it is the fundamental material of our reality. Einstein showed us that time isn't just something that passes by us like a wind. It's a direction. It is a dimension. Just as you can move left or right, forward or back, up or down, you're also always moving through time. It's the fourth dimension, as real and as essential as the 3 dimensions of space we can point to as part of the landscape. And this new landscape, this space-time, has one supreme, unbreakable rule. It's a speed limit for the entire cosmos. It is the speed of light. Now this is where our minds really have to stretch, so just relax and let the idea wash over you. The speed of light in a vacuum is constant. That doesn't just mean it's fast or fast. It means it is the same for everyone, no matter what. Imagine you're standing still on a dark field and you turn on a flashlight. You would see that beam of light race away from you at the speed of light, about 186,000 miles per second. But now imagine you are in a rocket ship traveling at an incredible 100,000 miles per second and you turn on the same flashlight pointing it forward. Common sense tells us we should just add the speeds together. But the universe says no. From your perspective on that fast-moving rocket, you would still see the light race away from you at the exact same 186,000 miles per second. And someone standing still on the field watching you fly by would also see that beam of light moving at that exact same speed. This is the universe's one non-negotiable law. The speed of light is absolute. So if the speed of light must stay the same for everyone, but we know that speed is just distance divided by time, something has to give. That something is space and time itself. To protect this one golden rule, the universe makes space and time flexible. They become personal, they become relative. This is the heart of Einstein's special theory of relativity. If you move very, very fast, your clock, your biology, your very experience of time literally slows down compared to someone standing still. This is what we call time dilation. At the same time, the universe in the direction you're moving would appear to squish or contract. Space itself often shrinks. It's a cosmic trade-off. Space-time stretches and squeezes itself all to ensure that one number, the speed of light, remains absolute for all observers. This idea alone was enough to change human history. But Einstein wasn't done. He spent another 10 years wondering, what about gravity? This force that Newton described as a mysterious invisible pull between two objects. How did it fit into this new flexible space-time? He came to an even more profound conclusion. A realization that is perhaps the most beautiful in all of physics. Gravity is not a force, it's not a pull reaching across empty space. Gravity is the shape of space-time itself. This is his general theory of relativity. Think of space-time as a vast, flat, stretched-out trampoline. If it's empty, it's flat. But if you place a heavy object like a bowling ball in the middle, what happens? The fabric sinks, it curves, it warps. Now, if you roll a small marble nearby, it doesn't get pulled by the bowling ball. It simply follows the curve in the fabric that the bowling ball created. It's following the straightest, easiest path it can on a curved surface. That is gravity. Mass and energy, and through his famous equation, E equals mc squared. We know they are two forms of the same thing. They tell spacetime how to curve, and in return the curvature of spacetime tells matter how to move. The Earth is not being held in orbit by a magical invisible rope from the Sun. The Sun is just so massive that it creates a profound dip in the fabric of spacetime like that bowling ball, and the Earth, like the marble, is continuously rolling along the edge of that dip. It thinks it's travelling in a straight line, but it's travelling in a straight line through a curved space. We right now are not being pulled down to the floor. The enormous mass of the Earth has warped the spacetime around us, and we are simply following the natural straightest path through that warped geometry, which happens to be down. How did he even guess this? He used his famous thought experiments. Imagine he said you're in a windowless elevator floating in deep space far from any planet. You're weightless as suddenly a rocket on the bottom of the elevator fires and it begins to accelerate upwards. You would be pressed to the floor. Now, how would that feeling be any different from the elevator suddenly being placed on the surface of the Earth where gravity presses you to the floor? His answer was, you cannot tell the difference. From inside that box, acceleration and gravity are indistinguishable. This was his equivalence principle. He realized they must be two sides of the same coin. Gravity is a form of acceleration. And this isn't just a history, it is a measurable physical fact. Because gravity is the curvature of space-time, it means that time itself is affected by gravity. Time runs slower in stronger gravity. This has been proven. Scientists have taken two perfectly synchronized atomic clocks. They left one at sea level and flew the other one up in a high-altitude airplane. When the plane landed, the clock that had been higher up where gravity is just slightly weaker had run a tiny, tiny fraction of a second faster than the clock on the ground. Your head right now is aging just a little bit faster than your feet. The GPS satellites that orbit our planet have to constantly correct their clocks for this very effect. If they didn't, the whole system would fail in minutes. So the universe we inhabit is not a collection of objects sitting in a box. The universe is the box, and the box is active. It's dynamic. It's a geometric landscape. The paths of planets, the bending of starlight around distant galaxies, the very flow of time, it's all geometry. The ancient Greeks believed that God is a geometer. They had no idea how right they were. The entire cosmos in all its majesty and all its motion is simply a grand unfolding story, written in the language of the geometry of space-time. One of the most bizarre and fascinating ideas to come from Einstein's theory is called time dilation. In simple terms, it means that time does not pass at the same rate for everyone. The speed at which you travel through space directly affects the speed at which you travel through time. This idea completely shatters our everyday human experience where we assume that 1 second on our watch is 1 second for every other person on the planet. But reality, it turns out, is much stranger. Let's explore this with a famous thought experiment. Imagine a futuristic spaceship that can travel incredibly fast, say at 95% of the speed of light. Inside this spaceship, an astronaut is going about her business. She makes a cup of coffee, listens to a song, and checks her watch. For her inside the ship, everything feels completely normal. The coffee brews in a normal amount of time, the song plays at its regular speed, and her heart beats at a normal rate. 1 minute on her clock feels exactly like 1 minute. Now let's imagine we are standing on Earth watching her spaceship fly past through a powerful telescope. From our perspective, something astonishing is happening. We would see the astronaut moving in slow motion. Her actions would be drawn out and sluggish. The coffee that took her 5 minutes to brew by her clock might take an hour to brew by our clock on Earth. The 3-minute song might take 30 minutes to finish. Her watch to us would be ticking incredibly slowly. This is the central point of time dilation. The faster an object moves relative to you, the slower you will observe its time passing. The most important thing to understand is that this is not an illusion. It isn't a trick of the light or a delay in the signal like a lag in a video call. It is a genuine physical distortion of time itself. From our point of view, on Earth, time for the astronaut is truly and fundamentally passing at a slower rate. But here is the paradox from her point of view: her time is normal. If she looked back at Earth, she would see us moving in slow motion, assuming she wasn't accelerating. Relativity tells us that both points of view are equally real and equally valid within their own frame of reference. This sounds like science fiction, but we have concrete real-world proof that this happens every single day. The best evidence comes from tiny unstable particles called muons, pronounced muons. These particles are created many miles up in the Earth's upper atmosphere when high-energy cosmic rays from space smash into air molecules. Muons have a very, very short lifespan. If you have a muon just sitting still in a laboratory, it will decay, break apart into other particles in an average of just 2.2 microseconds. A microsecond is 1/1,000,000th of a second. Even travelling at nearly the speed of light, this lifespan is so short that a muon should only be able to travel about 600 meters or a few city blocks before it vanishes. Yet these particles are created 10 to 20 kilometers or many miles up in the atmosphere, and we detect them in huge numbers right here on the surface of the Earth. How do they survive a journey that should be impossibly long? Relativity provides the answer, and it can be seen from two different but equally correct perspectives. First, let's look at it from our perspective on Earth. We are standing on the ground watching the muon speeding down towards us. Because the muon is moving so fast at over 99% of the speed of light, its internal clock slows down. Time dilates for the muon. From our point of view, its 2.2 microsecond lifespan gets stretched out perhaps to 40 or 50 microseconds. This extended lifespan in our time frame gives the muon just enough time to complete the long journey from the upper atmosphere to the ground before it decays. Now let's look at it from the muon's perspective. If you could shrink down and ride on the muon, your time would feel completely normal. Your clock would tick as it always does, and your lifespan would still be only 2.2 microseconds. So how do you reach the ground? From your fast-moving perspective, it is not time that changes, it's space. The atmosphere is rushing towards you at near light speed. This extreme speed causes the distance to change. The 10 kilometers of atmosphere from your point of view becomes length contracted. The entire distance from the upper atmosphere to the ground shrinks to only a few hundred meters. This much shorter journey is a distance you can easily cross in your normal short lifespan of 2.2 microseconds. Both explanations describe the same event. One sees time stretch, the other sees distance shrink. Both are real and both prove that Einstein's theory is correct. This effect isn't just for tiny particles. We have to account for it in our own technology. Massive machines called particle accelerators, like the Large Hadron Collider in Switzerland, accelerate tiny particles to 99, that is, 99.9999% of the speed of light. To the scientists in the lab, the lifespan of the particles they create is stretched by thousands of times. If the engineers who built these machines did not factor time dilation into their calculations, their experiments would fail every single time. The magnets and detectors are all timed perfectly to account for the fact that time for these particles is running thousands of times slower than our own. This all leads to the famous twin paradox. Imagine two identical twins. One, an astronaut, gets in a spaceship and travels to a distant star at 95% of the speed of light. The other twin stays on Earth. For the twin on Earth, the journey takes 50 years. When the spaceship returns, the Earthbound twin is an old person. But because the astronaut twin was traveling so fast, his time slowed down. For him, the journey may have only taken 5 years. When he steps off the ship, he is 45 years younger than his own twin. People ask, but from the astronaut's point of view, wasn't the Earth moving away? Wouldn't the Earthbound twin be younger? This is not a real paradox because their situations are not the same. The twin on Earth stayed in one steady reference frame. The astronaut, however, had to accelerate to get up to speed, decelerate to stop and turn around, and accelerate again to come home. This act of accelerating and changing direction breaks the symmetry. It is the travelling twin who will unambiguously be younger upon returning. We even have direct proof of this on a much smaller scale. Astronauts on the International Space Station ISS are orbiting the Earth at over 17,000 miles per hour. This isn't close to the speed of light, but it's fast. After spending 6 months on the ISS, an astronaut returns to Earth having aged slightly less than the rest of us. They are a tiny fraction of a second younger than they would have been if they had stayed home. This has been measured with incredibly precise atomic clocks. In conclusion, time is not a simple universal metronome. It is a flexible, malleable part of the universe. It is a dimension woven together with space to form a four-dimensional fabric called spacetime. Every object in the universe is always moving through spacetime at one constant speed, the speed of light. If you're standing still, you are using all of that motion to travel through the time dimension. But as you begin to move through space, you have to borrow some of that motion from the time dimension. The faster you move through space, the slower you are forced to move through time. Now let's turn our gaze to the most powerful, most mysterious force in the cosmos: gravity. We think of it as something that pulls us down, that holds the planets in their orbits. But Einstein showed us it's something far more profound. Gravity is the shape of space and time itself. Imagine again that great cosmic fabric. When you place a massive object on it, like a star or a planet, it creates a dip, a curve. Planets roll around this curve, and that's what we call an orbit. But it's not just space that curves. Time does too. This is where our minds really have to stretch. The stronger the pull of gravity, the slower time flows. This isn't a theory, it's a fact we measure every single day. The GPS satellites orbiting high above the Earth are in a region of slightly weaker gravity than we are down here on the surface. Because of this, their clocks actually run a tiny bit faster than our clocks on the ground. If scientists didn't account for this gravitational time dilation, your GPS would be off by miles within a single day. A person living at sea level ages just a tiny fraction of a second slower than someone living on a high mountain. The difference is minuscule, but it is real. Time is not a universal metronome ticking at the same pace for everyone everywhere. It is flexible, and gravity is what pulls on its hands. And as with all things in the universe, we can ask, what is the extreme? What happens when gravity becomes absolute? The answer is a black hole. This is what happens when a truly massive star dies. It collapses under its own immense weight, squeezing all of its matter down, 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 past the point of no return into a single infinitely tiny point. A point of infinite density. We call this the singularity. Surrounding this impossible point is a boundary. It's not a physical surface. You can't touch it. It is not made of matter. It is a boundary of time and space. It is the place where the pull of gravity becomes so strong that nothing, not even light itself, the fastest thing in the universe, can escape. We call this the event horizon. It is quite literally the edge of the visible universe. It is the point of no return. The true mystery of the black hole isn't just what's inside it, but what happens at this edge. And the answer depends entirely on who you ask. This is where reality itself seems to split in two. Let's imagine you're an astronaut and you have decided to take this journey. You're going to fall into a giant black hole. I will stay behind in a spaceship a safe distance away watching you. From your perspective as you fall, everything feels relatively normal. You're in free fall, so you feel weightless. You look at your watch, it's ticking normally. Your heart beats at its usual rhythm. Your thoughts are clear. You approach the event horizon, that invisible line, and then you cross it. There's no bang, no flash, no wall. You just pass through. You are now inside. You can still see the universe you left behind, but it's getting distorted. You are now in a region of space-time that is falling inward faster than light toward the center. You cannot turn back. The singularity is not a place in front of you anymore. It is your future. It is the end of time itself for you. And from the moment you cross the horizon, you have a finite, limited amount of time, maybe minutes, maybe hours, depending on the black hole's size, before you reach that center. Your journey is personal and it is final. Now let's talk about my perspective. I'm in my ship watching you through a powerful telescope. As you get closer and closer to the event horizon, I see something very different. I see you start to slow down. Your movements, your waves goodbye, they become agonizingly slow. The light signals from your suit, they have to fight against that immense gravity to reach me. This battle costs them energy, and as they lose energy, they stretch out, shifting from blue to green to red. You become redshifted. You get slower and redder and dimmer. As you get infinitely close to that horizon, I see your time slow down until it stops. From my point of view, you are frozen in time forever right at the edge. You never cross. You are just stuck. A dim red frozen image of an astronaut imprinted on the boundary of the black hole for all of eternity. Your now has stretched into my forever. So who is right? Are you inside living out your final moments, or are you frozen on the outside for all of time? The strange and beautiful answer of relativity is that both are true. Reality is relative. There is your reality and there is my reality, and they are both valid. This is the very idea explored in movies like Interstellar. The crew lands on a planet orbiting close to a supermassive black hole. Down there, gravity is so intense that for every 1 hour they spend on the surface, 7 years pass for their crewmate in orbit and for everyone back on Earth. When they return, they are only a few hours older, but the universe they left behind is decades in the future. They didn't travel through time, but they allowed time to travel past them. And this slowing isn't just a trick of clocks. From my perspective, watching you fall, your thoughts would slow down, your biology would slow down. Every chemical reaction in your body, every electrical pulse in your brain, would appear to me to be grinding to a halt stretched out over billions of years. This brings us to a deep philosophical question. If your present and my present can be so dramatically, so fundamentally different, what is now? What is real? The universe doesn't seem to have a single master clock. It's a vast collection of individual clocks, all ticking at their own rates, all experiencing their own private flow of time. That haunting image of you falling into that darkness is perhaps the most profound journey anyone could take. It's not just a journey through space, it is a journey out of time. It's like slipping sideways out of our shared universe. From our perspective, you're stretched into an infinite moment, a story that never ends. But from yours, you just fall. You reach the end, and you take the secret of what lies at the heart of the universe with you. It's one thing to talk about clocks on spaceships moving near the speed of light or the fabric of space bending around a black hole. It can all feel very distant, like a science fiction story that has no real impact on our daily lives. But the truth is, you almost certainly use Albert Einstein's strangest ideas every single day. If you've ever used a map on your phone, a navigation system in a car, or even just had your phone tag a photo with your location, you have personally relied on the theory of relativity. Without it, the entire system we call GPS, or the Global Positioning System, would fail in minutes. Let's pull this abstract physics down to Earth, right into the palm of your hand. How does your phone know where it is? The basic idea is a brilliant bit of cosmic clock watching. High above you, a network or constellation of about 30 satellites is orbiting the Earth. Each of these satellites has an incredibly precise atomic clock on board. These clocks are so stable they might only lose or gain a second over millions of years. As they fly, each satellite is constantly broadcasting a simple radio signal over and over. This signal essentially shouts two things: I am satellite number 24, and, according to my clock, the precise time is insert time here. Your phone's GPS receiver is a tiny passive listener. It picks up these signals. Because light and radio waves travel at a fixed known speed, the speed of light about 300,000 kilometers per second. It takes a tiny amount of time for the signal to travel from the satellite down to you. Your phone's receiver gets the message and compares the satellite's timestamp to its own internal clock. It notes the difference. For example, if the satellite's signal says the time is 12:00,000, but your phone's clock says the time is 12:07. When the signal arrives, your phone knows the signal took 7/100ths of a second to reach it. This is the key. Your phone can now do a simple calculation: time delay multiplied by the speed of light equals distance. It knows it is a specific distance from that satellite. This isn't enough to know your location, however. It just tells you that you are somewhere on the surface of a giant imaginary sphere centered on that satellite. But your phone is smart. It listens for at least 4 satellites at once. By knowing its exact distance from 4 different known points in space, it can perform a calculation called trilateration. It finds the one single point on the surface of the Earth where all 4 of those imaginary spheres intersect. That point is you. This whole system, however, has a critical weakness. It is built entirely on time. The speed of light is enormous. To get your position accurate to within a few meters, which is what we expect, the timing across the entire system must be accurate to within a few nanoseconds, a few billionths of a second. If the clocks on the satellites and the clocks on Earth disagree by even a tiny fraction of a second, the entire system breaks down. And this is where Einstein enters the picture because his theories prove that the clocks must disagree. Two of his most powerful ideas are at play. First, there is the special theory of relativity. This theory, which deals with high speeds, makes a bizarre prediction: the faster you move, the slower time passes for you relative to someone standing still. This isn't a trick. Time itself literally stretches. The GPS satellites are not standing still. They are whipping around the planet at about 14,000 kilometers per hour. This incredible speed means that according to special relativity, the atomic clocks on board the satellites should run slower than the clocks on the ground. The math shows this effect alone would cause them to lose about 7 microseconds, 7 millionths of a second every single day. Second, there is the general theory of relativity. This is Einstein's theory of gravity, and it is even stranger. It says that gravity is not a pull, but rather a bending or warping of space and time by mass and energy. One of its key consequences is that time flows differently depending on the strength of gravity. Time passes slower in a stronger gravitational field. Think of gravity as a drag on the flow of time. The GPS satellites are orbiting about 20,000 kilometers above the surface. Up there, the pull of Earth's gravity is significantly weaker than it is down here where we live. Because the satellites are in a weaker gravitational field, general relativity predicts their clocks should run faster than ours. This effect is much more powerful than the speed-related one. The calculations show that this gravitational effect alone would cause the satellite clocks to gain about 45 microseconds every single day. So we have two competing relativistic effects. Speed special relativity clocks run slower by 7 microseconds per day. Gravity general relativity clocks run faster by 45 microseconds per day. When you put them together, the net result is easy to find. A gain of 45 minus a loss of 7 leaves a net gain of 38 microseconds every day. 45 and 7 is 38. The clocks on the satellites naturally want to run faster than the clocks on Earth by 38 millionths of a second every single day. This might sound completely trivial. Who could possibly care about 38 millionths of a second? Your GPS receiver cares. In fact, this tiny error would be completely catastrophic. Let's see what would happen if the engineers who built GPS had decided to ignore Einstein. The system calculates your distance by multiplying a time delay by the speed of light. If the satellite clocks are wrong by 38 microseconds after just one day, the system's calculation of your distance will be wrong. The error would be 0.038 seconds multiplied by roughly 300,000 meters per second. This equals 11,400 meters. That's 11.4 kilometers or about 7 miles. This is not a small error. It means that after just one day of operation, an uncorrected GPS system would tell you that your house is 7 miles away from where it actually is, and this error would accumulate. After 2 days, it would be off by over 22 kilometers. After just 1 week, the map on your phone would be useless. It would place you in a completely different town. Einstein's physics is not just an academic curiosity. It is a mandatory engineering requirement for our modern world. The people who built the GPS system knew this from the start. They couldn't just fix it later with software on the ground. The error is built into the very fabric of spacetime. So what did they do? They used Einstein's own equations against the problem. Before the satellites are even launched, the engineers deliberately build the atomic clocks to be wrong. They tune them on the ground to run just a tiny bit slow, precisely 38 microseconds slow per day. Then they launch them into orbit. Once the satellite is in space, the laws of relativity take over. The satellite's high-speed special relativity tries to slow the clock down by 7 microseconds, while its high altitude and weaker gravity, general relativity tries to speed it up by 45 microseconds. The two effects combine, speeding the clock up by the net 38 microseconds, which perfectly cancels out the 38 microsecond slow setting the engineers built into it. The result? From the perspective of us on the ground, the satellite clock now ticks at the exact same rate as the master clocks on Earth. The system works. This is a profoundly humbling thing to realize. The universe does not care about our common sense. Our intuition, built from a lifetime of moving at slow speeds in a single strong gravitational field, is simply wrong. Time is not absolute. It is flexible, and it is warped by both speed and gravity. To build a system that can pinpoint a location on Earth, we must accept the universe's rules and build our technology to obey them. So the next time you pull out your phone to look up directions or see where your delivery driver is, take a second to appreciate what you're holding. You're not just holding a clever piece of technology. You're holding a device that is in constant perfect sync with a cosmic dance, a device that only works because it accounts for the fundamental, beautiful and deeply strange curvature of space-time itself. Let's settle back in and turn our thoughts to the very stage upon which this all plays out. We have talked about stars and galaxies, but what about the space between them? What about the time that allows their stories to unfold? We used to think of them as separate. Space was just an empty, dark, passive box, and time was a universal, unchangeable clock ticking away at the same rate for everyone everywhere. It was a simple, comfortable idea, and it was completely wrong. Einstein's great insight was that space and time are not separate. They are two parts of a single unified whole. They are woven together into one dynamic four-dimensional fabric. He called it space-time. This isn't just a poetic metaphor. It is the fundamental material of our reality. It can stretch, it can twist, it can ripple, and it can warp. And this warping, this curving is what we experience as gravity. There is a beautiful idea often summed up by the physicist John Wheeler that describes the endless relationship between this fabric and everything in the universe. It goes like this. Matter tells space-time how to curve and space-time tells matter how to move. It's an eternal cosmic dance. Imagine space-time as a vast, invisible, stretchy trampoline. Now take a heavy object like a bowling ball and place it in the center. What happens? The fabric of the trampoline sags. It creates a deep curving dip. That is the first part of the dance matter. The bowling ball telling space-time, the trampoline, how to curve. The more massive the object, the deeper the curve. Our sun creates a huge sloping valley in space-time. Now for the second part of the dance, roll a small marble across the trampoline near the bowling ball. The marble isn't pulled to the ball by some mysterious invisible force. The marble is simply trying to roll in a straight line, but the path itself is curved. The fabric of the trampoline is now telling the marble how to move. It follows the slope, spiraling around and around that central dip. That is orbit, that is gravity. The Earth is not being pulled by the Sun. The Earth is simply following the straightest possible path it can through the curved geometry of space-time that the Sun has created. We are stuck to the Earth not because a force is holding us down, but because the Earth's own mass warps the tiny patch of space-time we are in, and the fabric is in a sense constantly pushing us toward the center by its very shape. This was and still is a mind-bending idea. When Einstein published it, it was just a beautiful theory, a set of equations on paper. It needed proof. That proof came in 1919 thanks to an astronomer named Sir Arthur Eddington. Eddington knew that if Einstein was right and massive objects curve space-time, then the sun's massive gravity should be able to do something amazing. It should be able to bend light itself. Light from a distant star passing near the sun should follow that curve. The only problem, the sun is so bright you can't see the stars near it. But Eddington knew of a solution, a total solar eclipse. He travelled to the island of Principe off the coast of Africa and waited. As the moon slid in front of the sun, plunging the world into a strange sudden darkness, the stars popped out. He frantically took photographs of the stars that appeared right next to the sun's blacked-out edge. Months later, he compared those photos to pictures of the very same star field taken when the sun was in a different part of the sky. The result was world-changing. The positions of the stars in the eclipse photos had shifted. The starlight on its long journey to Earth had passed by the sun and followed the curve in space-time. Einstein was right. Gravity wasn't a force, it was the geometry of the cosmos. But this unified fabric has an even stranger, more profound implication. If time is truly just another dimension, the fourth dimension, just as real as length, width, and height, it might mean that our entire understanding of past, present, and future is an illusion. This leads to an idea known as the block universe. Think of it this way. Imagine a loaf of bread. The entire loaf exists from the first slice to the last. We just experience it one slice at a time. The dimension of length in the bread exists all at once. What if time is like that? What if the entire length of time from the Big Bang to the very end of the universe exists as a complete four-dimensional block? What if the past is not gone and the future is not unwritten? What if they are just other locations in space-time? In this view, your birth is not a vanished memory. It is a permanent coordinate in the block. And this very moment, as you listen to my voice, is another coordinate. And your future, it's also there just further down the block. That powerful feeling we have of now, of the present moment being the only real thing, might just be a trick of our consciousness. It's like a spotlight moving along the loaf of bread. The present is simply the slice of the block that our awareness is currently illuminating. It is a completely subjective slice through this four-dimensional reality. What's even stranger is that Einstein's theory shows that the angle of your slice depends on how you are moving. It's called the relativity of simultaneity. It means that if you are standing still and I'm flying by in a very fast spaceship, we will have different definitions of now. We will literally disagree on which events in the universe are happening at the same time. You might see two distant supernovas explode into different galaxies at the exact same moment, but from my spaceship moving relative to you, I would see one explode and then perhaps hours later see the other one explode. And the most bizarre part is, we would both be right. There is no single universal now that everyone in the universe can agree on. The present is personal. So if this block universe is real, what are we? What are you? You are not just a three-dimensional person moving through time. In this four-dimensional reality, you are a complete and finished object. You are a story. Scientists call it your world line. If we could see from outside this block, you would look like a long, intricate pattern. A line that starts at the place and time of your birth and stretches and winds its way through all of space-time. Every action, every choice, every place you have ever been is part of this pattern. It traces your path from childhood to this very night, all the way to the coordinate of your final moment. Your entire life, from its first second to its last, may exist as a single beautiful, unchanging shape. A permanent and unique signature woven directly into the grand, silent fabric of reality. This is perhaps the most difficult and most profound consequence of Einstein's theory. We have seen that time can slow down and lengths can shrink, but this next idea challenges the very meaning of the word now. In our daily lives, we assume that now is a universal concept. We imagine a single cosmic present that sweeps across the entire universe at the same time. We think that at this exact instant, someone in another galaxy is experiencing the same now. Special relativity completely destroys this comfortable idea. The theory proves that there is no such thing as a universal now. Universe now. This concept is called the relativity of simultaneity. In simple terms, it means that two events that happen at the exact same time for one person can happen at different times for another person if that second person is moving. And here is the crucial part: both people are correct. To understand this, we must use Einstein's most famous thought experiment. Imagine a long train car perfectly straight with glass walls. This train is moving at an incredibly high speed, perhaps half the speed of light. Inside the train, standing precisely in the middle, is a person. Let's call her Mavis. At the very front of her car is a sensor, and at the very back of her car is another sensor. A light bulb is attached to the ceiling, also exactly in the middle. At a certain moment, the light bulb flashes. From Mavis's point of view, she is standing still. The light flash happens in the middle of her car. The light spreads out in all directions at the speed of light. Because she is exactly in the middle, the light has to travel the same distance to reach the front sensor as it does to reach the back sensor. Since the speed of light is constant, the light rays arrive at the front sensor and the back sensor at the exact same instant. For Mavis, these two events, light hits the front, light hits the back, are simultaneous. They happen at the same time. This is her reality. Now let's watch this same event from the outside. Standing on the station platform watching the high-speed train pass by is another person. Let's call him Stanley. From Stanley's perspective on the platform, he also sees the flash of light happen in the middle of the car. He also knows the speed of light is constant. But from his point of view, the train car is moving. As the light rays travel from the center, the train itself is moving forward. Let's follow the light. The ray of light traveling towards the back of the train is moving to hit a target, the back sensor, that is actively moving toward it. The back of the train is rushing to meet the light ray. The ray of light traveling towards the front of the train has a much harder job. It is moving to hit a target, the front sensor, that is actively moving away from it. The front of the train is running away from the light ray. Both light rays travel at the exact same speed, the speed of light. But the light going to the back has a much shorter distance to cover, because the back of the train is moving toward it. The light going to the front has a much longer distance to cover, because the front of the train is moving away from it. Therefore, from Stanley's perspective on the platform, he must see the light hit the back sensor first. A moment later, he will see the light catch up to the front sensor and hit it. For Stanley, the two events are not simultaneous. So who is right, Mavis, who saw the lights hit at the same time, or Stanley, who saw the backlight hit first? Einstein's revolutionary answer is, they are both right. There is no real or actual order. There is only the order you observe from your frame of reference. Mavis's now is a slice of time where both events happen together. Stanley's now is a different slice where the back event happens before the front event. This has enormous consequences. It means that the clear, sharp division we feel between the past, the present, and the future is not a fundamental feature of the universe. It is a human illusion. If you and I are moving relative to each other, your present moment is a different slice of time from my present moment. An event that you consider to be in your future might for someone else moving at a high speed already be in their past. An event I think is happening right now might for another observer not have happened yet. This shatters the idea of the universe as a single story unfolding moment by moment. So if time is this flexible, is anything solid? Yes. One thing remains absolute for everyone: causality. This is the law of cause and effect. If one event causes another event, for example, if you throw a ball event A and it breaks a window, event B, then everyone in the universe, no matter how they are moving, will agree that event A happened before event B. The order of events can only be scrambled if the events are too far apart in space to influence each other, like the two ends of the train car. You can never see an effect happen before its cause. The universe does not allow its own history to be nonsensical. The past, understood as the set of all events that could possibly have affected you, is fixed. This leads to a new and strange picture of reality. Many physicists believe this implies something called the block universe. Instead of thinking of time as a flowing river where the now is real and the future is unwritten, this model suggests that all of time already exists. Imagine the universe as a four-dimensional block containing all of space and all of time. In this block, the past, present, and future all exist together, just as here and there exist in space. The dinosaurs are not gone, they are just located at a different time coordinate in the past section of the block. Your future is also already there, in the block. What we experience as the flow of time is just our consciousness moving through this static block, illuminating one now after another, like a spotlight moving down a long fixed line. From this perspective, time does not pass, it simply is. The ultimate conclusion is that time is profoundly personal. It is not a single grand cosmic clock. Each of us carries our own clock, which ticks at its own rate. And more deeply, each of us carries our own present moment. We are each experiencing our own unique slice of the universe, and what you call now is fundamentally and measurably different from what someone else calls now. Let's sink deeper into this idea, this strange and beautiful concept of time. We've been treating it as something that flows a river that carries us along. But what if that feeling, that sensation of now, is the greatest illusion of all? What if reality is more like a block? This is an idea from physics known as the block universe. I want you to truly try and feel this idea, to wrap your mind around it as you settle in. Imagine all of reality, all of space, and all of time existing at once. It's not a story that's being written, it's a book that is already finished. In this book, the first page of the Big Bang is just as real as the last page, whatever that might be. And your life is a sentence or perhaps a chapter written within that book. We, with our human consciousness, are like a reader, with a spotlight shining it on one word at a time. That word is what we call now. As we move the spotlight, the previous word feels like the past, and the word that's coming up still in the dark feels like the future. But the whole time, all the words are already there on the page. In this view, time is not a river. It is a dimension. It's just like the three dimensions of space we know so well. You can point up, you can point left, you can point forward. In the block universe, you can also point to yesterday or next year. They are just directions, locations. The past isn't gone. It's just back there in the time dimension. The future is not unformed. It's over there, a place in the time dimension we just haven't arrived at yet. This immediately brings up a huge question. If this is true, why do we feel so stuck? Why can we only move in one direction? We can move left or right, forward or back in space, but in time we are relentlessly pushed from the past toward the future. Why? This is what scientists call the arrow of time, and the best answer we have for it is a single powerful word: entropy. Entropy is just a simple fundamental rule of the universe. It says that things tend to move from a state of order to a state of disorder. Think of an egg. An intact egg is a very ordered, complex system. If you drop it, it shatters into a disordered mess on the floor. That's entropy in action. And you will never ever see the reverse happen. You will never see a shattered egg on the floor suddenly pull itself back together, leap up into your hand and become a whole perfect egg again. The universe itself is like that egg. It started in a very low entropy, highly ordered state at the Big Bang, and ever since then it has been moving toward a state of higher and higher disorder. Stars burn out, heat spreads out, things break down. This physical one-way street, the thermodynamic arrow of time, is what gives us our psychological arrow of time. Why do we remember the past but not the future? Because the past is where the order was. Our minds work by creating records, by taking snapshots of things that were. These records, our memories, are imprints of a lower entropy state. We don't remember the future because the future is by definition a state of higher disorder. It hasn't left that clean imprint on us yet. We can only guess at it. So we feel like we are moving away from the ordered past and into the disordered future. This one-way process of increasing entropy gives us the profound, inescapable feeling of time's flow. But if the block is real, if the future is already over there, just as solid and real as the past, what does that mean for us? What does that mean for our choices? This is perhaps the most difficult part of this idea to hold. If the book is already written, what does it mean when I feel like I am choosing what to do next? Does free will even exist? Perhaps we are thinking about choice in the wrong way. When you read a novel, the main character makes a choice. They decide to take the job or go on the journey or say, "I love you." That choice is a fundamental part of who they are. It's written on the page. It is the story. What if our lives are the same? The future isn't just there. You are there. Your decision, the difficult process of you weighing your options, the anxiety, the relief, the eventual choice you make, that is part of the structure. The feeling of making a choice is simply the subjective first-person experience of your consciousness arriving at that specific point in the block universe. You aren't changing the future, you are the future. Your act of choosing is the event that was always there, woven into the fabric of space-time. Your will, your thoughts, your struggles. They are the very threads that make up the part of the tapestry. This idea can feel cold at first. It can feel like we're just puppets. But I invite you to find a different perspective. I invite you to find the profound comfort in it. If the block universe is real, then nothing is ever truly lost. Every moment you've ever lived is not gone. It has not vanished into some non-existent past. It is preserved perfectly and eternally in its own location in space-time. That moment when you were a child laughing so hard you couldn't breathe, that is still happening. It is happening in its coordinate in the block universe right now and forever. That conversation with someone you loved and lost, it is not an echo. It is a real place. The sound of their voice, the look in their eyes, it is all held permanent and safe. Every mistake, every triumph, every quiet, forgotten afternoon, all of it exists. Your entire life from its very first moment to its very last is a single, complete and permanent part of reality. And this changes how we think about the end. In this view, death is not an erasure. It is not the end of you. It is simply the end of your world line, the end of your particular thread as it moves through the time dimension. But the entire thread still exists. Your life as a whole is a complete and finished work of art. And even after the artist has put down the brush, the painting itself endures. It is all there. Every joy, every tear, every breath. All of it, all of you, permanent, complete, eternal. We have journeyed through the strange and wonderful physics of a four-dimensional world where time is a direction, not a river. We have built a new map of reality. Now we arrive at the final, most profound and most human destination. We must ask the ultimate philosophical question. In a universe like this, what does it truly mean to exist? We have been trained our entire lives to believe that to exist means to be here right now. Existence is the present moment. The past is gone, a collection of ghosts and memories. The future is unformed, a void of possibilities. Only the now is real. But as we have seen, the solid ground of now has crumbled beneath our feet. If two people moving at different speeds can disagree on what now is, if my present is part of your past and your present is part of my future, then now is not a universal fact. It is a personal perspective. This leads to a staggering conclusion. If the present is relative, then existence itself must also be relative. The things you see as existing in your present moment are just one slice of the complete four-dimensional reality. Another observer moving differently would slice reality at a different angle and declare a different set of events as existing. Your reality, your now, is fundamentally your own. It is not the reality, it is a reality. This does not mean that anything you imagine is real. It means that what you perceive as the single unfolding present moment is just your unique cross-section of a much larger already existing four-dimensional structure. This shatters our most basic intuition. We think of our existence as a single point, the bright dot of me that moves from birth to death. But the four-dimensional view, often called the block universe, demands a radical reimagining of ourselves. Your existence is not the point. Your existence is the entire path. You are not just the you reading the sentence. You're also the baby you were, the child you were, the teenager you were, and the old person you will become. All of it. All at once. Think of it this way: in space, you are not just a point. You have a physical body, you have a front and a back, a top and a bottom. You exist as a three-dimensional object. Now add the fourth dimension, time. In this four-dimensional space-time, you are not a body that endures through time, you are a world line. Imagine a long continuous sculpture that begins at your birth and ends at your death. This entire sculpture, this time worm, is you. The person you were 10 years ago is not gone. They are just a different part of your total structure, just as your feet are a different part of your body than your head. Both are equally real components of the whole you. Existence, therefore, is not the fleeting experience of the present. Existence is the entirety of your world line frozen in the block of space-time. But this immediately creates a deep and troubling problem. If this is true, why does it not feel this way? Why do we feel so intensely that time is flowing? Why do we only experience one single solitary moment at a time? This is the great concealment, the profound veil of consciousness. The most powerful way to understand this is through a metaphor. Imagine your entire life, your complete world line from birth to death is an enormous, magnificent painting. The painting is already finished. Every event, every joy, every sorrow, every choice is already there, a permanent part of the canvas. It is a complete and static work of art. Now imagine consciousness as a single tiny spotlight. This spotlight does not create the painting, it only illuminates it. The spotlight begins at one end of the canvas, your birth, and slowly, steadily moves across it, revealing one tiny patch of the painting at a time. This tiny illuminated patch is what you call the present moment. The part of the painting the spotlight has already passed over is the past. The part it has not yet reached is the future. The feeling of time passing is just the sensation of this spotlight of awareness moving along the already completed structure. The illusion of flow comes from the fact that our consciousness only grants us access to one moment at a time. We are veiled from seeing the entire painting at once. We are built to experience our own four-dimensional sculpture one slice at a time. This leads us to the greatest mystery of all, a question that physics alone cannot answer: the mystery of the observer. Physics is brilliant at describing the painting. General relativity describes the shape of the canvas itself, how mass and energy warp the four-dimensional space-time. Quantum mechanics describes the intricate, bizarre rules of the paint at the smallest scales. Physics describes the structure of reality in breathtaking detail. But nowhere in any equation from Einstein to Schrödinger is there a single term that explains the spotlight. Physics describes the four-dimensional block, but it does not explain the feeling of experiencing it. It does not explain why there is a spotlight of subjective awareness moving through this block at all. It doesn't explain why you are you tied to this specific world line experiencing this specific now. This is the hard problem of consciousness. What is this internal light that reads the script of the universe? What is this observer that senses the structure? Physics describes a world of objects, forces, and dimensions. It describes a what. It does not describe the how it feels to be a what. This suggests that a complete picture of existence requires two ingredients. We need both parts of the equation. Existence as we live it is the product of structure and experience. The structure is the objective four-dimensional block universe. It is the painting, the complete map of all events in time and space. It is impersonal, static, and described by the laws of physics. It simply is. The experience is the subjective first-person spotlight. It is the knower, the feeler, the observer. It is your personal, private, internal world of awareness that moves through the structure and brings it to life. Without the structure, experience would have nothing to experience. It would be a spotlight shining in a total void. Without the experience, the structure would be a dark, unwatched movie, a magnificent symphony played in an empty hall. It would be a universe without witness. True existence, the reality we know, seems to require both. It is the fixed four-dimensional sculpture being perceived by the mysterious light of consciousness. So where does this leave us, the human beings living out these lives, if the painting is already finished? If our worldlines are already written into the fabric of space-time? What is the point? Does this mean we are just puppets? Does it erase free will? Does it make our lives meaningless? This is the final and most important philosophical turn. The role of the human is not perhaps to change the structure. The role of the human is to find meaning within the structure. Even if your life is a fixed story, you are the one living it. The experience of it is new to you. Think of your favorite movie or book. You know how it ends. The script is fixed. The story is unchanging. Does that make your experience of watching it meaningless? No. You still feel the suspense, the joyless sadness, and the love. The meaning is not in the outcome which is already set, but in the journey and the experience of the story itself. Our lives could be the same. The future may be as real and fixed as the past, but it is hidden from us by the veil of our consciousness. Our choice may not be the act of creating a new future, but the act of experiencing the part of the structure we call making a decision. The struggle, the effort, the moral dilemma all afit is a real and permanent part of your world line. It is a real part of the painting. The meaning of our existence then is not to fight against the structure, but to imbue it with value. We are the universe's way of experiencing itself. We are the spotlight. Our purpose is to shine as brightly as we can. Our role is to live our pre-written story with as much compassion, courage, love, and wonder as possible. The meaning is not in altering the painting. The meaning is the painting and the profound, mysterious, and beautiful act of seeing it one moment at a time. Existence is the universe's grand structure, and it is the personal experience of that structure. We need both. We have travelled a long way together on this journey, exploring the deepest and strangest ideas about our cosmos. We began with a simple intuitive feeling, the feeling of now. We started with the assumption that the present moment is special, that the past is gone, and that the future is an unwritten, open possibility. This feeling, the idea of a universal present, that is constantly collapsing into the past to make way for the future, feels like common sense. But as we saw physics, especially Albert Einstein's theories, began to dismantle this comfortable idea, we learned about the relativity of simultaneity, a concept that proves two different observers moving at different speeds can and will disagree on the order of events. They will have a fundamental disagreement about what is happening now in the universe. If there is no universal now, if your now is different from my now, then the idea of a single special present moment that all of Atus share simply dissolves. This collapse of a universal now forced us to consider a much more radical, and for many a much more difficult concept, the block universe. This is the idea that all of time, every moment from the Big Bang to the final cold end of the universe, is equally real. The past, the present, and the future all coexist. Time doesn't flow. It just is. This brings us to the philosophy of living in such a universe. If this idea is true, what does it mean for us? The most powerful way to understand this is through the metaphor of the film reel. Imagine you are in a dark theatre watching a movie. On the screen, the story is unfolding. There is drama, suspense, laughter, and tears. The characters are making choices, events are happening in sequence, and it all feels incredibly alive and in motion. But where is the rest of the movie? It is all spooled onto the film reel in the projector. The entire story, from the opening scene to the final credits, already exists all at once as a single complete object. The frame showing the hero's birth and the frame showing their final moments are both equally real, existing simultaneously on that reel of film. The block universe theory suggests that we are the movie, and our consciousness is the projector light. The present is simply the single frame that your consciousness is illuminating at this very moment. The story feels like it's moving. It feels like it's flowing from one event to the next, but that is only because our consciousness is viewing the frames one by one in a specific order. The entire reel, your entire life, already exists. The film itself is static. The experience of watching it is what we call the flow of time. This immediately raises the most important question. If the whole film reel is there, why can we only watch it in one direction? Why can we remember the past, the frames we've already seen but not the future, the frames that are coming up on the reel? As we've discussed before, the answer seems to lie in a fundamental law of physics, the second law of thermodynamics. This is the law of entropy. Entropy is simply put a measure of disorder. The universe as a whole is always moving from a state of order to a state of disorder. A hot cup of coffee, an ordered state with heat concentrated in one place, will always cool down, spreading its heat into the disordered air of the room. An egg, a highly ordered complex structure, can be dropped and shattered into a disordered mess. You will never see a shattered egg on the floor spontaneously pull itself back together into a whole egg. You will never see all the cold air in your room rush into your cup to make it hot again. The arrow of time, our sense that time has a forward direction, is really just the arrow of entropy. We experience time flowing forward because that is the only direction in which disorder increases. Our own brains, our thoughts, and our memories are all physical processes. To form a memory, our brain has to do work which burns energy and releases heat, increasing the total entropy of the universe. We remember the past because the past had lower entropy. We don't remember the future because the future has higher entropy. Our psychological sense of time's flow is bound to this irreversible process of increasing disorder. We are simply processing the static frames of the film reel in the only direction that our physics will allow. So this forces us to confront the core question: what is time? Is it a real fundamental property of the universe like space? Is it a fourth dimension, a direction you can point in just like left, right, up and down? In this view, time is a physical part of the space-time block. Or is time something else? Is time a property of consciousness? Perhaps the block universe just is silent and static, and time is the word we use for the experience of our consciousness moving through it. Maybe time is an illusion, a beautiful and persistent story our minds tell us, to make sense of a reality that is too enormous and too static to perceive all at once. The universe itself doesn't happen. It simply is. We are the event. We are the happening. This philosophy, if we choose to accept it, changes everything about how we view our lives. We are taught to think of ourselves as a single point, a self that is desperately trying to move along a line. We are this tiny, now, fleeing from the past which is gone and racing toward a future which is terrifyingly unknown. We are filled with regret for past frames and anxiety for future ones. The block universe philosophy offers a different, more profound and perhaps more peaceful conclusion. You are not the tiny point of light moving on the line. You are the entire line. You are not just the person you are today. You are the 5-year-old child filled with wonder who still exists permanently in a past frame. You are the 15-year-old full of confusion and passion. You are the 30-year-old, the 50-year-old, and the 80-year-old. All of those versions of you are equally real, all existing as part of the complete tapestry of your life within the block. Your life is not a fleeting wisp of smoke that vanishes. It is a permanent sculpture. It is a complete story, finished and whole, existing forever in the great library of the cosmos. The joy you felt 10 years ago is not gone. It is a permanent part of that structure. The pain you felt is also part of it, as is the peace you will find. You are not a traveller passing through this world. You are the entire journey, start to finish, simply being experienced one beautiful, precious moment at a time. This leads us to the most difficult and most human question of all. If the future is already written, if all of time is a fixed landscape that we are just passing through, then what is the point if my struggles, my choices, and my triumphs are already set in stone? Where is the meaning in my life? This question can feel like a cold, empty void. It seems to suggest our lives are a pointless movie playing for an empty theatre, but perhaps we have been looking for meaning in the wrong place. We are used to thinking that meaning comes from our ability to change the future. We believe our lives matter if our choices create a different outcome. We find purpose in the fight, in the possibility of failure or success. If that possibility is removed, we feel our purpose is stolen. Let's try a profound shift in perspective. What if meaning does not come from altering the future, but from the shape of the path we actually walk? The meaning of a journey isn't just about the destination you could have gone to. It's about the road you did take, the sights you saw, and the person you were along the way. Your life's meaning is not found in the futures you avoided, but in the intricate, unique, and complex reality of the life you're actually living. Think of meaning as a pattern, like a magnificent piece of art or a complex symphony. If you look at a great painting, you don't find its meaning in a single brushstroke. You cannot point to one splotch of colour and say this is the meaning. The meaning is in the entire structure, the relationship between all the colours, the light and the shadow, the composition of the whole. A single note is not the symphony. The symphony is the pattern that all the notes create together, from the first sound to the final silence. Our lives are like this. Your meaning is not in this one now moment. It is in the entire pattern of your life, from your first breath to your last. It is the complete story with all its joys, sorrows, triumphs, and failures. These things are not separate events. They are all connected, and the meaning is the shape of that connection. In this view, time is the architecture for meaning. It is the framework that holds the experience together. It's the canvas that the painting is on, or the silence that the music is built against. Time provides the structure, the before and after, that allows a story to be a story. Without this architecture, our experiences would just be a random, meaningless jumble. Time is what gives our life its shape, its narrative, and its form. This leads to a beautiful and powerful idea. The universe is like a vast, infinite library of experiences. Every possible life, every possible story, every history of every star and every planet already exists as a complete book in this library. We are not writing our book as we go, we are living it. Our consciousness, our feeling of now, is like a reader's attention moving through the pages of a story that is already complete. Does a great novel like War and Peace or Moby Dick lose its meaning just because the ending is already written? Of course not. The meaning is in the story, the character's journey, the emotional struggles, the beauty of the language. Knowing the book is finished doesn't make reading it pointless. The experience of the story is the entire point. In the same way, we are living through the story of our lives. The story is already there, complete and whole in the great library of time. Our role is to experience it to be that story. Far from destroying meaning, this idea of a fixed, determined universe makes meaning eternal. Think about it: if the future was truly open and changeable and the past was truly gone, then every moment would be born only to be instantly destroyed. The joy you felt 10 years ago would not just be a memory, it would be annihilated, vanished forever. The person you were yesterday would be gone. But in this block universe, where all of time is equally real, nothing is ever lost. Your past is not gone. The moments of love you felt, the times you laughed until you cried, the profound achievements of your life, they are not fading memories. They are permanent locations in reality. They exist back there in time just as surely as this city exists over there in Stenspeyer. That moment of joy is a permanent and real feature of the universe. Determinism doesn't erase meaning, it saves it. It chisels your life in its entirety into the permanent stone of reality. This brings us to a final stunning conclusion. This perspective doesn't make our moments less important, it makes every single moment infinitely more important. If we believe a moment only matters because of the future it might create, we are missing the beauty of the moment itself. This new view teaches us the opposite. This now, this very second, is not just a stepping stone to something else. It is the destination. It is final, unique, and irreplaceable, because this moment is a permanent part of the universe's eternal structure, has a weight and a significance we could hardly imagine. This view does not ask us to give up and do nothing. It asks us to wake up and pay attention. It asks us to live this moment with our full awareness, because the experience we are having right now is our eternal contribution to the tapestry of reality. We are not just making memories that will fade, we are inhabiting a permanent, unchangeable and vital piece of the cosmic artwork. The meaning of your life is not in what you will do or what you might have done. The meaning is in what you are right now forever. And so we arrive at the end of our long journey together. We've drifted through nebulae, listened for the echoes of the ancient universe, and questioned the very ground beneath our feet. Now we stand at a vantage point, looking back at the path we've travelled from a familiar clockwork world to one that is profoundly strange, geometric and beautiful. Our journey began in a place of comfort. It was the universe of Isaac Newton, a world of simple, absolute rules. In this world, space was a vast, dark, empty stage, a static backdrop. And time was a universal drumbeat, a relentless cosmic metronome. 1 second passed on Earth and 1 second passed on the farthest galaxy. The now was absolute. It was a comforting thought, a shared river carrying all of us downstream together. This intuition is baked into our very being. It's the world we feel we live in. But our journey took a turn. It led us to a quiet patent clerk named Albert Einstein, who looked at this comfortable stage and decided to set it on fire. Not with malice, but with a curiosity that would remake our understanding of reality. He proposed something that even a century later feels like science fiction. He said that the stage is the actor, that space is not separate from time. They are a single interwoven fabric, space-time. And this fabric, it is not static. It is dynamic, it's alive, it bends, it warps, it stretches. A planet doesn't move in a straight line because a force called gravity pulls it. No, a planet moves in the straightest possible line through a curved geometry. The mass of a star like the Sun creates a deep dimple in this space-time fabric, like a bowling ball on a trampoline. And our Earth, like a small marble, is just rolling around the edge of that curve. Gravity is not a force, it is the shape of reality. This was the first great shift, but it came with a consequence, a beautiful, terrifying and profound consequence that is the single most important key to understanding our modern cosmos. If gravity and speed can stretch and bend space-time, it means they also stretch and bend time. The universal drumbeat is gone. gone. This is the hardest leap for us to make, but it is the central one. The now we all thought we shared, it's an illusion. It is not real. Imagine a friend on a spaceship travelling away from you at an immense speed. If you could both hold up a clock, you would see their clock ticking slower than yours, and they would see your clock ticking slower than theirs. You would both be right. The very rate at which time passes is not fixed. It is relative to where you are and how you're moving. If our clocks can't agree, then the very idea of simultaneously or at the same time breaks down over large distances. My now is not your now. Your now is not the now of someone in the Andromeda galaxy. The concept of a universal present moment, a cosmic now, that slices across the entire universe simply does not exist in physics. What does this mean for us as we drift off to sleep? It means that time is not something we share universally. Time is something we carry with us. It is personal, it is local. You have your time and I have mine. We each drag our own little bubble of now through the cosmos, and our bubbles are beautifully, wonderfully, permanently out of sync. This shatters our intuition about flow. We feel time flowing, don't we? We feel the past slipping away, the future rushing toward us. But if there is no universal now, what is this flow? This leads us to a staggering idea, one that many physicists believe is the logical conclusion of Einstein's geometry. The idea is that the universe doesn't happen. The universe simply is. Think of your life as a book. When you are reading, page 50, page 1 still exists. And page 300, the end of the story, also already exists. They are all part of the complete object, the book. You, the reader, are the one experiencing the flow as your consciousness moves from one page to the next. But the story itself, the whole shape of it, exists all at once. What if the universe is like that? What if the past, the present, and the future all exist? Not as a happening, but as a being. A complete four-dimensional space-time sculpture. All of history, all of the future laid out as a static, beautiful, complex shape. In this view, the flow of time is not a property of the universe. It is a property of us, of our consciousness. We are the readers turning the pages of space-time, and our limited perception creates this powerful moving illusion of passage. The universe is, it does not become. And this brings us to our final quiet reflection. We have been taught to think of time as a road, a line, a river, something we move along or something that flows past us. But perhaps that metaphor is wrong. Time is not a line we walk, time is a shape we inhabit. Think about that. You are not just a three-dimensional object, you are a four-dimensional one. You have height, width, and depth, but you also have duration. You are not a snapshot. You're a story. Your entire life from your first breath to your last is a single continuous four-dimensional shape. A pattern, a thread woven into the grandest tapestry of all. That tapestry is space-time. It is the ultimate shape, the geometry that contains all other geometries, and this is the final beautiful truth Einstein gave us. This fabric bends and stretches to hold the gravity of a star. It ripples with the echoes of colliding black holes, and it holds us. It holds every moment, every lost loved one, every forgotten memory, every brilliant fleeting spark of joy, every act of kindness. They are not gone, they are simply in a different place in the block of space-time. They are all part of the permanent finished sculpture. Every meaning we have ever created, every love we have ever felt, it is all held permanently within that shape. We are not just living in the universe, we are a part of the universe's very geometry. Our lives, our stories, our durations are woven into its fabric. The cosmos is not a cold, empty stage. It is a warm, dynamic, geometric embrace. That great, curving cosmic shape, it holds us. It holds every moment. It holds everything.